Hello, and in today's chemistry video, we're going to start talking about gravimetric stoichiometry. Gravimetric stoichiometry is the study of mass-to-mass stoichiometry. So we're going to get a reaction. We're going to have a mass of one compound, and it's going to ask us to predict the mass of another compound in that reaction. Because we will be converting from mass to moles and moles to mass, we will need the molar mass of both of our substances. So, example 13, calculate the mass of iron 3 oxide produced by the reaction of 500 grams of iron with oxygen from the air. First thing we're going to have to do is we're going to have to create a skeleton equation and then balance that skeleton equation. So we're calculating the mass of iron 3 oxide produced by the reaction of iron with oxygen. So the first thing we have to do is we have to have iron reacting with oxygen. And this is going to produce iron 3 oxide solid. Perfect. Now what we have to do is we have to try and balance this equation. So we will start at the most complicated and finish up with the least complicated. I have 3 oxygens over here and 2 oxygens over there. We're going to need 2 and 3. We have 4 irons over here, and we have 1 iron over here, so we will change that to 4. No problemo. Now what we want to do is we want to list all of the information that we can possibly have about these compounds. We know that we want to calculate the mass of iron 3 oxide. That's what we're looking for. This mass of iron 3 oxide is a big old question mark. So we're looking for the mass in grams. It's going to be produced by the reaction of 500 grams of iron with oxygen from the air. So we know that we're going to have 500 grams of Fe. We're always labeling our values. So this is grams of iron. We don't know the mass in grams of iron 3 oxide. What we're doing down here below the reaction is we're putting basically the information that we know or information that might be useful for us during this problem. Think of it as puzzle pieces, and we're going to put the puzzle pieces together when we do our stoichiometry problem. So we have the mass of our iron. We want the mass of our iron 3 oxide. The only way I can go from the amount of one substance to the amount of another substance is by talking about moles. Well, if I want to convert this into moles, I have to have the molar mass of iron. So the molar mass of iron is 55.85 grams, and I'm going to label it per 1 mole of iron. So there, in 1 mole of iron, there is 55.8 grams of iron. Well, we need the mass of iron 3 oxide, so we're going to have the molar mass of iron 3 oxide. No problem. 159.7 grams of iron 3 oxide per 1 mole of iron 3 oxide. Perfect. So let's think about this. We can go from grams of our iron to moles of our iron using the molar mass, but in order to convert from moles of one substance to moles of another substance, we have to have the molar ratio. Now here in the middle, I'm going to put the molar ratio because the molar ratio is going to convert from one substance to another. And we always write our molar ratio as unknown over given. So there are 2 moles of Fe2O3 for every 4 moles of iron. Now we have all of our puzzle pieces. We'll be able to go from iron grams of iron to moles of iron to moles of iron 3 oxide to grams of iron 3 oxide, and that's exactly what we want. So let's start putting all of our puzzle pieces together. When we're doing stoichiometry problems, we always start with what we want. Okay, so we want the mass of iron 3 oxide. So the mass measured in grams of iron 3 oxide. Well, what do we want? We want to start with what we want. Okay, no problem. So let's start with whatever has grams of iron 3 oxide. That's what we want. So that's what I'm going to start with. I'm going to start with that unit. Whatever has that unit on the top of our fraction, that's what I'm going to start with. Sure, no problem. 159.7 grams of Fe2O3 for every 1 mole of Fe2O3. Now our goal is to finish with this unit and cancel out every other unit. So I have to cancel out moles of iron 3 oxide. What else has moles of iron 3 oxide in it? Well, our molar ratio has moles of iron 3 oxide. So I'm going to multiply by 2 moles Fe2O3 for every 4 moles of iron. Perfect. Now my moles of Fe2O3 are going to cancel with my moles of Fe2O3, but I'm left with moles of iron. Well, what has moles of iron? Well, I see here the molar mass of iron has moles of iron. So I'm going to take this, but I'm going to flip it. I'm going to take the reciprocal of that so that moles of Fe is in the top, times 1 mole of iron for every 55.85 grams of iron. So my moles of iron cancel with my moles of iron, and I'm going to be left with grams of iron in the bottom. Well, the only thing left that has grams of iron was that mass of iron that we started with. So if I multiply by 500 grams of iron over 1, because there's nothing in the bottom of that fraction, there's just a 1. So my grams of iron cancels with my grams of iron. So if I multiply all this, 159.7 times 2 times 500, all divided by 4 times 55.8, I am going to get 714.8612 yada 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 grams of Fe2O3. If I round this to the 3 significant digits that I see here, well, 3 significant digits is going to give us 715 grams of iron 3 oxide.